Hey guys, we're starting a new topic today. It's called logs and exponentials. So today's heading, or what we're looking at today, is exponential graphs. Now we have actually already seen some of these earlier in year 11, but we go into more detail today. So let's look at the basics. So don't forget to copy all of this into your book like it would be on the board in front of you. Basically, if I'm just going to look at what I call the OG, the original exponential graph, it's in the form y equals some number to the power of x, okay? So no other transformations affecting it. These features occur. But again, these three features only happen if there's no other transformations affecting it. I'll show you later what I mean by that, but for now, the first thing is it has a y-intercept at 1 because anything to the power of 0 is 1, okay? So when you substitute in your x value being 0, what do we get? 1. So if I do a small graph of this, we've seen at the beginning of year 11, our exponential graphs look something like that graph, passing through at 1. Okay, so that's our first feature, y-intercept at 1. The second feature is that it has a range of 0 to infinity. So what that means is there are only positive values you're going to get. When you sub in a negative number, it's still going to spit out a positive. And this here is the reasoning I've given as an example. If I look at the point x equals negative 1, around here somewhere, if I sub negative 1, let's say this graph, instead of being just some random exponential graph, it is y equals 2 to the power of x instead of a to the power of x. When I sub in a negative 1 in my x value, I get, okay, well, 2 to the power of negative 1. Well, we know, based on our index laws, that's 2 to the power of positive 1 when it's on the bottom of a fraction, which is a half. So see how, even when you plug in a negative value, we're still getting a positive answer. And that's why we have this range given to us here. So the last one is that our x-axis is an asymptote. So whenever you're sketching these exponentials, I'm being very picky. You must show that it's approaching, okay? Don't flatten it out. It has to show, don't hit the axis, it's approaching it. All right, so let's start looking at now some transformations. More specifically, negatives. What negatives have as an impact? Well, first things first, here's our normal exponential passing through at 1. So I'll start by drawing the negative of that. So if I represent this exponential with f of x rather than y, this next graph we're going to draw is negative of f of x. So we know that whenever we draw a negative graph, it's just the original flipped along the x-axis, so flipped upside down. So now what that means is we're going to look more like this and pass through at negative 1. So it's the original graph flipped upside down. Okay, let's go back to the original, but this time we're drawing to the power of negative x, okay? So what that would be is f of negative x that we're drawing. So we just think about, well, you could think of this one as it's going to affect the gradient, okay? It's making the gradient negative, all right? Just like a straight line, when the number in front of the x, it represents the gradient. Think of it like that. Because what this does now is it takes our original graph, but this time gives it a negative gradient. Sorry, my lines are a bit shaky on this device. Oops, but passing through a positive one. So that's the best way I think about those. So then the last one, it's going to be negative of f of negative x. So it's going to be just this negative x flipped upside down, because the negative out the front, as we know, just flips it upside down, which will give me something like this, passing through at negative 1. Okay, so that's how our negatives affect the graph. So make sure you get that down. Now let's look at numbers. What I've done this time is I've screenshotted from Desmos, just because I know that my sketching is a bit dodgy on here. I want you to have a really close look at these three graphs. So I've drawn y equals 2 to the x, but then I've shown some small adjustments. The blue graph shows when you times the x by 2. The green graph though shows when you times the whole thing by 2. So slightly different transformations, and check out how we have different graphs. So let's have a look at what happens. Let's take the x value at -1. When I sub in -1 into each of these, well, the first one's 2 to the -1, which will give me, we know, a positive 1/2. The next one's going to be 2 timesing by 2 to the -1, which is the same thing as 2 to the power of -2, which would give me a 1/4. And the last one, it's 2 timesing by 2 to the -1. So 2 timesing by 1/2, which gives me 1. So now let's look at that on our graph. So the first one should be at about 1/2. So red, when we sub in -1, we're at 1/2, yep. The blue one, we're smaller, we're lower. Okay, we get a smaller number, which is a 1/4, yep. And the green one, we've gotten bigger because we're multiplying the whole thing by 2. Okay, so that makes sense that it should be double the value of the original. So 2 lots of 1/2, yep, that gives me 1. So you can see how this small number affects it in so many different ways. Okay, so putting the 2 in a different spot changes the transformation completely. Alright, so basically if I had to generalize it, I would say that the power, when we times the power by 2, it's making the whole thing sharper. But if I generalize and try and explain the green one, when we times the entire exponential by a number, it's just doubling the original exponential. So what we're about to do is an exercise now where we're going to sketch a bunch of exponentials. What I want to see on every sketch are 3 things. I want a point that your exponential passes through. The reason I want this is because imagine on us sketching on paper having to sketch the red and the blue graph there. It would be very hard for us to distinguish on our sketch that doesn't necessarily have to be exactly to scale on a grid, how we would differ between those two. And the way we do it is by plotting a point like I've done there to show what point that graph goes through. The other thing I like labelled is the asymptote, and then of course any intercepts. So in saying that, let's have a look at this example here. So you can pause the video here and give it a go. Otherwise I'm going to go through it with you because you're going to do a exercise soon in your textbook where you'll practice plenty of these. So let's have a look. The first one, 4 to the power of x. Well, I'll try and keep them color synced. So we know, okay, well, let's pick our point first that we're going to label. If I think about what happens at x equals 1. Well, at x equals 1, I have 4 to the power of 1. Okay, so y is equal to 4. So there's my first point, 1, 4. So I want to label that, just as I said before, labeling your point. I know this passes through at 1, and I know it has an asymptote, which we represent generally with a dotted line. So there's our first graph, and I'm just going to represent that as A. So now B, what we want to draw is the negative of that. Okay, so remember the negative flips it upside down. So this time though, it's going to go through 1, -4. So, but pass through at -1. Let's see how good my drawings are. Not bad. So I'll label that with B. So now we go to C. We want f of -x. So remember this is our gradient changing, which means it's going to pass through, and you can check by doing a substitution with these if you like, but it's going to pass through at -1, 4. It'll pass through at 1. And try not to hit the axes like I did. All right. So last of all, then we have negative of that. So flipping that upside down, it's going to come through and pass at -1, -4. Passing through at -1. And that is D. Okay. So, there we have it. Now, I might just add an E. Let's add E. Let's go f of x plus 1. The only transformation I haven't spoken about now is when we're adding an answer. Okay, I'll do this one in, let's go navy blue. So adding 1 or subtracting 1, anything on the end of it, we know just as normal graphs is going to shift the whole thing up. So if I do f of x and a plus 1, it's going to simply be the normal graph but plussing 1, which means it's going to go through here at 2 rather than 1. It's going to now have a new asymptote at 1, and it'll pass through at 1, 5 now. So let's see my sketch, joining all of that up. There, roughly, I have my graph, and that's E. Okay, so now you've had a look at a bunch of different transformations. What I would like you to do is have a go at the following exercises on exercise 801, question 1, 2, 4, all of them for me. Alright, don't forget to post into Teams if you have any questions.